In this example, we will look at paralleling resistors. So here we are asked to calculate the power absorbed by the 1 ohm resistor right here. And so what we really need to know is what is the current, so we can say that the power in the 1 ohm is equal to I squared R. So we need to write a loop equation, single loop, and to do that we notice that, or we are suspicious that this here can be reduced to something simpler. Specifically, we can redraw this. We see that the 10 ohm and the 40 ohm are in parallel, and the 15 ohm and the 60 ohm are in parallel. So we can, in fact, the simple way to solve this is we can look at all of the, we can reduce all of this to a single voltage source and a single resistor. The voltage source is going to be 150 volts minus 30 volts. So if you look at the polarity, got the plus sign here, that polarity opposes the 150, and so we have a net 120 volts. It doesn't matter that the voltage source is here. It could have been placed here. It could have been placed anywhere around the loop, and it would still have contributed to a net effort, if you will, to push current I through the lumped amount of resistance that we have. This resistance, RE, is going to be equal to 2 ohms, this 2 ohms, plus this 3 ohms, plus the 1 ohm, plus the 2 ohms here. And then let's look at this. We see here that actually what we have is 2 resistors in series. That's the 6 and the 13, and 2 more resistors in series, 2 and 12. Those are connected together, but then we have actually a shorting wire across there. So the whole net effect of this is 0 ohms thanks to this shorting. So we'll say plus 0. That's for this. And the only element resistance that's left is these guys right here, which would be 10 in parallel with 40 plus 15 in parallel with 60. You can solve this as 10 times 40 over 10 plus 40. So this is 400 over 50, or 8 ohms. And this is 15 times 60 over 15 plus 60, which is 75. And that is equivalent to 20, I believe. Yep, 20 ohms. Okay, so this is equivalent to, no, that can't be, sorry, 12 ohms. This is equivalent to 12 ohms, and these two together are equivalent to 8 ohms. So let's rewrite RE. RE is 2 plus 3 plus 1, that's 6, plus 2 is 8, plus 12 plus 8 is equal to 28 ohms. And so I is equal to 120 volts divided by 28 ohms, which gives 4.29 amps, and which leads to power in the 1 ohm resistor as being 1 ohm times 4.29 amps squared, or 18.4 watts.